Very good evening to all of you. So thank you all for logging in on time today. So it's my pleasure in welcoming you all for today's session on Industry 4.0 for manufacturing. So today we have with us Mr. Mihir Gangoly to talk to us on this topic. Before we start, I would like to introduce the speaker. Very good evening to all of you. So thank you all for logging in on time today. Mr. Mihir is a successful and visionary entrepreneur with over 26 years of industry experience. With a bachelor degree in computer engineering from RAIT Mumbai, he started his career in Sarla, where he scaled up to become a manager for the southern region in just a year. He then came back to start his company, Protocol Consultants, in 1994, which is one of India's first software services company focused on developing and implementing software to the manufacturing industry. With the vision to focus and convince customers to look at software automation systems at affordable cost. He was the first one to bring open industrial technologies like OPC in 2003, and since then has been propagating it by bringing in professional-based training services in this area. He's a pioneer in bringing IoT to India way back in 2010, when IoT was just a concept. Mr. Mihir has been successfully implementing unique concepts of automation in various industries like steel, food, and discrete manufacturing. And some of the most innovative technologies have been adopted for companies like ITC Food, Tata Cummins, Baba Atomic Research Center, Punjab State Electricity Board, West Bengal State Electricity Board, Madhya Pradesh State Electricity. He has reduced their operational costs and has increased their quality processes and adding important value to the existing profit margin. This deep experience in helping customers to increase efficiency by using automation and software tools has made him a much sought out person to go for Industry 4.0 solutions. In 2001, he was recognized by International Association of Business Leaders as a leader in bringing low-cost software automation technologies to small and medium manufacturing companies, allowing for them to also benefit from using online quality and automation system to improve manufacturing standards. So on behalf of TiE Chennai, it's my pleasure in welcoming you, sir. And I now request Mr. Mihir to take over.
Great. Thank you very much, Saurav, for that. Good afternoon, everyone. Like Saurav said, my name is Mihir Gangoly. Though my story and love for software started a little earlier when I was in the 8th standard, when we had very, very flimsy machines at that time with running 64 KB of RAM. We are used to luxuries which are much larger. But since then, my desire to bring and work with software has been that old. Engineering was just the add-on to get into industry. What's interesting today about today's session is that I also seem to be celebrating my 25th marriage anniversary, much to my wife's regret, saying that I'm busy with you guys. But it's a pleasure that I am doing this today because topics like Industry 4.4 are very close to my heart. And I would love to share with you all what I already have done and learned with customers and what we are already doing right now. So just to give you a quick idea, Protocol Automation Technology is a company I run. We have close to 3,000 customers in India, Middle East, and Canada, mainly, of course, in India, headquartered here in Bangalore. And our focus has always been to provide, platform-based rather than start development from scratch. We don't do software coding right from the beginning, allowing us to do delivery quite rapidly and delivery to clients. We worked initially when we came in 1994, most customers, at least manufacturing customers, weren't really ready to look at computers in the factory shop floor. To tell them that it would actually control the plant was a laughable matter at that time. But it was a tough sell at that point. I spent a lot of time in Chennai as well trying to convince customers there to start using visualization and control solutions. So it's been an interesting a ride from 1994 to now, where this is almost a default. Software on the shop floor has become standard, and a lot of things are happening with software. Today, I'm going to be sharing a little more. We are OPC solution experts, and we do certified training as well. So that's something that we do because we have brought OPC close to 2001. We do Industry 4.0 and IoT. Again, these are both jargon words, but I began this process very, very early. I think the earliest client was Bosch, and then ITC. So they did this long back, about 15 years back. So these are new jargons, but our focus has always been this. It's good to know that industries actually put a jargon to this and focusing to get here. Because we do IoT, we work a lot with embedded companies to custom build the IoT devices as well for our automation or advanced metering infrastructure and energy projects. So we do a lot of that. Thank you very much. I'm just seeing the chat bar. I can see a lot of wishes. Thank you very much for all the wishes. And finally, a core strength is actually to support customers. Once we install something or set it up, the idea is to actually make sure that we are there supporting solutions that are as old as 15 years and helping clients to upgrade and move from there to the next technologies that are there. Training is something we do believe, and that's something I focus on as well. So just to give you a quick overview of these spaces that my expertise lies, and my companies for that matter. On the right hand side, we broken up into two parts. We have infrastructure, where India is really doing a lot now. On the topmost, you'll see something called advanced metering infrastructure, where utilities have been trying to automate getting their distribution networks to get data and digitize them, bring information and know about consumption patterns, billing information, centralizing it. So a lot of work there. Those are the few of the examples that Saurabh shared with you. We have many more. About 8 states in India actually use our solutions there. Pro EMS is the energy solution that we do for manufacturing, where we don't sell it to the owner, we sell it to the CFO, the man who looks at money, and we connect energy to money, and then they react based on that. On the bottom right-hand side, I have the building management systems, which are normally used. A lot of them are in the metros that we're there. Chennai Metro, Bangalore Metro, Jaipur, Delhi, Calcutta Metro. All of these metros use our solutions for building management, which is basically managing the utilities in a building and allowing them to optimize and control it. Highway traffic management, when toll systems came, it was very interesting to see that our toll stretches that we keep traveling on and we pay money for is actually being monitored live, and diagnostics are done on all the equipments that are there on the toll roads. So we work with large companies like L&T to do that type of work. So these are the infrastructure type of experience that we bring, as well as on the left-hand side, the Industry 4.0, different components that can help us to, satisfy Industry 4.0. We have the OPC, which is the standard in manufacturing for bringing third-party communication and bridging communication in a complex automated factory shop floor. MIS is reporting, web-based, so customers who have many, many systems, if you go to a large factory, they invariably have something from Siemens, then something from ABB, something from Rockwell. They have different technologies, and the idea is to have a centralized point where they can consolidate information. The SCADA solution is the visualization and control solution that we have. And the MES is the tool that, in fact, we'll be sharing and talking about today as well for Industry 4.0. So today's agenda, as some of you would have seen already in the invite that was sent out, this is what we're going to be covering. Industry 4.0 and what industry needs to look at doing, because it's just a word and people are wondering what is it that really needs to be done? Where can they start? Then there are other terminologies like IoT and big data, and people are wondering when does that come into play as well? What tools are available right now that can actually start manufacturing companies to start looking and moving towards Industry 4.0? One of the things I will share today is that Industry 4.0 is not an instant solution. It's a thought-based solution that needs to be addressed, and it's a long-term solution that customers must look at. So manufacturing companies must look at Industry 4.0 in a 3-year to 4-year window, starting very basic and then moving upward. What departments can be brought in? Very important, because if you bring all of them in, then you gain in terms of why Industry 4.0 is there. And finally, a little bit about the AI part and the Industry 5.0 focus in terms of getting predictive information there. So this is going to be our agenda today, and I'll move along. Like Saurabh said, If you do have, any of you have questions as I present, please feel free to share them on the chat bar. And of course, I have a Q&A session at the end of our session as well. So a little bit of history for those who are not directly core in manufacturing. This is the history of how industry, the industry 4.0, 3.0, 2.0, 1.0 has been progressively working through in the world. In India, we are at 3.0. We haven't moved to 4.0. Very few clients, like I said, there are some large companies like Tata Steel, Bosch, ITCs. These are larger companies who already understood it or had companies that they were working with abroad that understood about this. But 3.0 is where most companies have started to reach in India, which is basically just automating their production as much as possible with electronics and IT. That's basically bringing information and at least being able to see what they're doing on the shop floor in terms of controlling machines and stuff like that. So this is where, maybe when I came in 1994, we were looking at trying to get people to get automated and get industry 3.0 there. But India's come a long way. 3.0 has advanced, and it's great to see that a lot of manufacturing by default, when they start well and decently automated to make sure that core processes are automated so quality can be maintained. But then what is Industry 4.0? Industry 4.0 was a jargon that came out in by Germany actually in 2011. And they basically want their companies to start looking at not only just doing basic automation, but realizing that the information flow of the data that was coming from a machine, how to integrate it with information technology. That means basically bring things together. So Industry 4.4 focus is very different. The challenges since 2011 to 2020 is that a lot of digital technology is now available to us, and therefore Industry 4.0 becomes of prime importance. The reason why there's so much noise around it in the past 3 years is because it's easy and economical to start using such solutions, and technologies around are very varied and available to use on a shop floor. So then people ask me always the next question is, then what does IoT really do, and how does it play an important part? And I think most of us already know. If you look at Internet of Things, it means that you're looking at devices connected through the internet, and there are many service sectors that have already started using this quite effectively. If you have used an Ola cab or an Uber, you would know that they've already begun doing that. It's your phone directly ordering for a service, or if you have used Swiggy to order food home, then you know that IoT has already been running for a while. So IoT has been there because it's been using the internet to start making people use system connect devices together. The issue always is, does a manufacturing organization really need IoT? Should they take it first? What should they do is the queries that normally come up. And IoT basically is internet. And therefore, most customers, when they're in manufacturing, we normally talk about what type of security will they have if they are going to push their data on the internet. And therefore, that becomes the prime importance, whether they want to put it on the internet and for what reasons. So if customers are looking at, or manufacturing is specifically looking at implementing IoT, it's a good idea to understand the impacts of IoT and how it would affect the different, the security issues that will be faced. Just to give a small insight, manufacturing industry is always about 5 to 6 years back in terms of the progress they make in IT. Very, very deliberately, they prefer to go slow. If you see operating systems on a factory shop floor, much older than the ones that we might have in at our home or in our laptops, especially the ones that are doing control and automating applications. And therefore, IoT becomes an important point, and you must actually make decisions as to whether this will make sense to you or not. So who in manufacturing can actually use IoT is the question that comes next. And basically, if I was a machine OEM and I manufactured a specific type of machine and I sold it to manufacturing, IoT would make sense to me. I would like to have my machine talk to me in my factory where I manufacture that machine and provide me with data about my machine and how my customer is using it. So it's interesting, IoT can be used in manufacturing, yet it can be specific to a machine where it would throw data to inform an OEM who's making this machine, how their machine performs. Is the customer actually using the machine within the parameters that they instructed the customer to use it in? So IoT helps to work with those kind of scenarios. Of course, if you have a large factory and you have a lot of manufacturing and you have a lot of data already, pushing this data onto cloud, which is basically the next topic that I wanted to share, is the big data part. People are wondering, if I have this information, which many plants do have, what can I do with this data? So when you have lots of data, big data is not only about the information from machines and sensors. It is also data that's connected to your ERP that's running there, or other software systems. It could be sales system, it could be distribution system, it could be all your systems that interconnect. And big data analysis says, let's look at all of your data, not only your factory data, and let's try to cross-reference them and create scenarios and for the management to help them to start analyzing what's going to come in the next 4 years. Can they increase market share? How would they do it? What would be the different things that they need to look at? So big data analysis is interesting. It's there in the world, but it's talked about. It's still in progress. It's a work in progress. In India, for sure, it's still a work in progress because we haven't yet done much of the IoT and bringing information from the factory shop floor yet. Automation is there, but we haven't really connected it. So big data is the future for sure, and it is part of Industry 4.0, and it is what Industry 4.0 propagates, because once you're able to bring information, then big data makes sense to be the next step for any organization if they're large enough. It's not for everybody. It requires enough data to crunch to start predicting and doing things. But I'll be sharing with you, like today I said, tools that will help us to focus on what we have now. So to help industry to focus, the idea is to then look at this in the future if they reach these type of points. So what are the typical problems that we're looking at? For companies that are looking at wondering, why should I go for Industry 4.0 when I'm already doing what I'm doing? I seem to be fine, everything's good, I don't really need to worry. So if your manufacturing operations are not agile enough or efficient, then Industry 4.0 will start helping you there. The second point is, if you have poor response to changing process events, so something happens, the temperature suddenly changes, and because of that you have your product quality changing, or customer requirements have changed. Customer says, I don't want 100 pieces now, can you change it to, or I want more, I want another 200 pieces. Market conditions, suddenly there's a strike, you realize supply cannot happen, can we stop it? Or the people who supply you raw materials suddenly cannot supply. What would happen then? So market conditions decide. COVID is a great example of creating a very complex market situation. How would you respond then, and what can you do then? Equipment failures, though people are adept at managing it, but if you have poor response to it, then Industry 4.0 is a great starting point to start getting you more agile in terms of these spaces as well. For most people, though they do this, it's all manually done. The key performance indicators, that's basically your measurement parameters. People need to know, how well am I doing? So they measure their machine speed or the number of products that come out every hour and stuff like that. And there are industry standards like OEE, which talk about equipment effectiveness and the efficiency basically of a machine. The problem with this is there is no analysis done beyond that. People do it for machines, not realizing that actually a factory shop floor is much larger. It's about departments, it's about the plant, it's about a line. So if a line has 50 machines, then if I just do OEE per machine, it's a very complex process to constantly understand what's really creating problems there. And Industry 4.0 addresses this space as well. One very important space that is missed is performance for the labor. That means the people working, the operators, am I doing KPIs for them? It's a very challenging process to manage and understand who's doing their job the best. Do I need to add more value? Can I do training? All of these are missing data. ERP analysis currently is based on assumed values. When I say assumed, I mean people type in data. So if someone asks them, can you tell me what could be the throughput? They will say, yeah, it's approximately this, and they'll give a number. And that number is what ERP uses. And because ERP is a static system, it takes time for the analysis to come there. It's not real, not in real time. Then gap analysis. Where is my problem? Currently, a factory shop floor is quite dynamic, and therefore gap analysis is missing. So these are the problems customers face. And the most importantly is material consumption patterns. They don't really know, like I shared with you, if you have poor response to market conditions or customer requirements change, then to have a clear focus in terms of where my materials are and what's happening becomes a challenge. So these are the problems that customers normally come with, because they're already automated. They're already doing manufacturing, they're pretty okay. These are additional things which if you are now struggling with, or if customers are struggling with, then these are the points that motivate any client to start looking for Industry 4.0. If most companies will not, much smaller companies might not bother about these spaces and might not spend energy doing this because the output volumes match the need for clients and stuff like that. Of course, they're normally under stress if the volumes go up. But these are the core points. If you focus on, you will realize that you will have the potential to start using Industry 4.0, and there'll be gain for sure. So what is Industry 4.0 for manufacturing? In very simple terms, it's about digitization. It just says automate your factory as much as possible. Of course, we can automate some machines, but there are places where it's almost impossible to automate. There are machines and equipments that people have bought that are electrical but not yet digitized. So digitized means getting that information and actually being able to see that information on a computer somewhere. So digitization is the core importance, but can you automate as much as you can? If you can you make sure information coming from everywhere is as digitized as possible? And to equip and to enable that, because in India, we do have a cross section of automation and manual processes in a factory. It's very typical. It's not unheard of. In fact, even abroad, I've been to factories internationally as well. And there are always processes that are not digitized yet. And Industry 4.0 only focuses on saying digitize as much as possible. How do we do this? Of course, if you've automated a machine, fantastic. We can pick information from the machine and from the sensors. But if it comes to manual type of processes, we are looking at operators getting equipped with computers, tablets, and smartphones, which are easily now available. In fact, there are industry grade tablets that can be put on a shop floor, which is, if you have a dirty environment, which the operator is working in, oily hands, you have terminals that can work on the shop floor as well. So the idea is to start even capturing data, even if you have a manual machine, which is doing a specific job, like maybe cutting metal sheet, which might be manual, and most of the processes are many places. Then the idea is to just ensure that if he's done the cutting, which order was he connected to, you can get information from him using web-enabled technologies. The reason why the focus is on web is because web makes systems very light. You can use low-cost equipments, and web is easy to reach to port them onto PCs, tablets, smartphones. It doesn't matter as long as you have a browser, which we all know. We use the internet, whether you press google.com on your phone or on a PC, you still see Google. So the idea is to use web-based systems to make data transfer easy and use technologies that are really, really light. This is an interesting point that Industry 4.0 focuses on, is abolish the pen and paper on the shop floor completely. It says try to get rid of any documentation on the shop floor. So the idea is to move out of pen and paper. Of course, when we have this slide popping up, most customers look at us aghast, wondering how the heck can I ever get pen and paper out? If you notice, even in your own companies, we all have registers for signing in, even if you're an employee. So we're used to writing stuff and putting it in a register. But because we're talking about digitization, the idea is eventually to abolish it. And this could be done in many, many ways. In India, we have, when you have a large factory shop floor, a lot of machines, you have electrical systems, you have machines, you have automation systems. All of that information doesn't need to come to the factory shop floor when issues occur on the shop floor. They can be brought and put onto, they can be digitized and therefore brought into the shop floor without actually physically bringing anything. As well as, since most companies also invest in ERP, the information is already existent in terms of a customer order and what needs to be produced. So if that's available, then on the shop floor, the idea is to make sure that information reaches without any paper and a file moving on the shop floor. One of the simple reasons is damage. Damage takes place to paper on a shop floor. Like I said, all shop floors aren't that clean and clear. So they do have issues. And one of the biggest reasons customers give feedback is that they can't find documents, for systems that were 5 or 10 year old or earlier, because they're missing. So the idea is to use digitization to also bring abolishing the pen and paper totally, whether it's authorizing something or reading something, is to make it all available on the shop floor. Finally, Industry 4.4 focuses on integration of all the information systems. So if you have automation, excellent, please bring it to a computer. If you have a quality system, bring it to a computer. If you have a maintenance system, bring it to a quality, bring it to an IT system. And if these IT systems are all independent, then the idea is to integrate all of them. ERP, other technologies like MES, bring them all together, or maybe a weighing system, whatever you have on the shop floor, bring it, integrate it, and make it all come together. If you can, that's the value add that's going to come. And the next slide that I share with you basically will give you an idea of what type of benefits customers can look at. So if you do look at Industry 4.0 and you do the different points that I shared, this is the type of things that get highlighted. On the top, you have a huge reduction in cycle times. Cycle time is basically the time taken for a raw materials to produce a final product which comes out. So that's cycle time. It could be across many machines. It could be one machine. It could be just a set of people, but that's a cycle time. If you implement the digitization technologies, you start reducing 40% of your cycle time reduction. What does that mean? Basically, it means obviously my efficiency goes up and I can produce more. So for the same time, the same line, you can start producing more. That's the focus of cycle time reduction. Data entry, if it's digitized, then I am just looking at people clicking some stuff on the shop floor, and therefore data entry completely goes away. I don't want people typing data. So the straight benefits from digitization is that data entry goes away. Especially if you integrate systems together, then there's no repeatability of data from one point to another. I don't retype a data from one screen to another screen or from a paper to a screen. Therefore, reducing data entry reduction, which is huge. Work in progress, WIP is work in progress reduction, 30%. These numbers that I'm sharing with you are global numbers that are done by independent bodies that do study with people who implement it. Like I said, Industry 4.0 is a jargon, but there are companies who have been implementing this for a while, for the past 20 years. People have been working towards this in the Western space, in the Western countries. India is just getting introduced to this now, though we have understood much of this from working with Japan and Germany and stuff like that. But just by putting and focusing on digitization, these are the core benefits that can happen. 75% paperwork can be reduced. The benefit straight away from all of this goes to the points below, which is basically lead time reduction. It means 25% I can make sure that lead times can reduce, making it efficient for me ordering what I need to order and have just enough material. My 28% in non-compliance reduction, 30% efficiency improvement, which is huge, If customers do 5%, it's amazing value they can get, but 30% is what customers have done. So there's a massive efficiency improvement. And finally, obviously, directly relating to quality. Like I said, if you look at it from a savings perspective, companies can look at anywhere between 2% to 5% savings year on year. And investment in systems like digitization and software that does all of this, the ROIs are anywhere between 12 to 18 months. So that's the type of savings customers can look at. And today, thanks to the COVID pandemic changing the way we're looking at how we work, the SaaS model suddenly gains a lot of focus. That is software as a service. Basically, you pay a monthly model or a quarterly model to companies that implement Industry 4.0. And therefore, instead of CapEx, which is spending maybe 25, 30, 50 lakhs or a crore sometimes, you end up spending this over a period of time, and it becomes part of OpEx, which is far easier to justify because the returns are already coming and you're paying a small value per month or per quarter to ensure that you can still get the benefits that we are sharing above. So in a 5-year period or a 3-year period, you actually start seeing huge gain. Like I said, if you had a CapEx investment, your ROI would be 12 to 18 months. But if it's OpEx, it's great. It's just a small figure, going on every month that doesn't hurt you because it just goes as fast up. And if you break the cost down to per machine, per operation, it really, really makes it insignificant. So that's the new thing that's arrived, the SaaS or the software as a service model, which is something that can benefit. So anybody looking at moving into these spaces should be asking this question: can I implement SaaS? And there are many cloud-based solutions now offering these things, but cloud means moving it outside or using Internet of Things. But if you're looking at local, having it everything within your factory, you can still implement SaaS. So this is just giving you an idea of the benefits to the cost ratios, so that you understand what type of investments might be there and what type of returns could be got from using the system. So what is the tool that I wanted to bring out with you guys that's already been there? and proven a long time, but it fits beautifully for us in terms of what Industry 4.0 does, is basically using an MES. An MES is a manufacturing execution system. Basically, you connect, monitor, analyze, and do some prediction. This has been around for the past 22 years in the Western spaces. In India, maybe around maybe around 15 years now. We had our first client 15 years back. So people have been thinking and understanding about the MES. So this is one of the most easiest, and it's the proven tools because it's not new. It's been there, and therefore everything that it does, directly highlights the different things that Industry 4.0 expects in terms of what needs to be done. So where does the MES really fit? The MES is, if you look at the bottom, we have something called as level 1, level 2. These are, again, jargons and standards that it's easy when you talk to a factory person. We talk about level 1, level 2 being the sensors and the automation systems there, control systems there. They are all sitting at level 1, level 2. Normally, level 3 has been missed, and therefore Industry 4.0 is not available to many in India. But we have gone to level 4, which is the ERP part. So many people have ERP, and then they have the level 1, level 2, which I told you was Industry 3.0. So the level 3 fits into the Industry 4.0 space, where looking at everything that's happening in terms of manufacturing, the quality people, the material movements, and the maintenance. These 4 departments fit here in the level 3. It's a special segment. This is a very old architecture diagram that I share with you. It's still the standard, and if you talk to anybody who is in automation and understands industry and manufacturing, this segment has always been there. It's just that in India, it hasn't been given too much importance. And now with the 4.0 and also with things that are happening in terms of getting more competitive, let's say China and manufacturing coming to India, we still need to have pricing that's attractive. So having an MES layer really, really brings those benefits that I shared in the slide before, where if you're looking at efficiency improvements and cycle time reductions, you can really, really address supply of your material at the prices still doing, and still earn more money out of it, or even reduce costs if required. So what exactly does it mean to have it in that layer? I'll just break it down quickly for you so it's easy to understand. The production definition is where we basically define everything related to production, which is, operators, machines. We should be able to define all of this. Maybe connection to the ERP systems, all of that information is defined here. What type of product I'm making, the product definitions. Then we have the schedule, because people make a schedule as to when I'm going to produce what based on the demand from the market. Finally, if I'm ready, then we dispatch that schedule to the shop floor. And then we have production progress. That means the actual in the line, what's happening, where a product is, which machine it's running on, who's doing that work, all of that data, the traceability and the tracking of that product. And finally, of course, the analysis and the performance. So that's what the production system looks at doing. The next is, of course, the quality, very important. Definition of a quality tests that have to be implemented. The checks, whether it's visual or measured, the executing of those quality tests, and finally the analysis. Did I have so much reject? What are the reasons why? What are the defects that I had? So that's the analysis that happens at quality. This is what I'm sharing with you is very typical scenario of what happens on a shop floor. And then finally, the maintenance people, important department according to me, neglected by many or not given enough value. But maintenance is a critical form because they are the ones who try to bring machines back online if something happens and are damaged. So having a clear maintenance plan of what needs to be serviced when, executing all of that, as well as doing analysis to find out how fast they really do it. Do they have spares and stuff like that on the shop floor? And finally, the material movement, dispatching of material from a store to a machine, the quantities consumed, the quantities moving from A to Y. Many people forget, and I'll share a quick example here. Materials is an ignored area only for people to understand. We did a work for a cement factory where it was the final point where the powdered cement had to be just bagged. And the issue there was that it's a 50 kg bag. And if they had a tolerance of, 50.05, kind of 50.5 grams, 0.5 grams that could go up, or 5 grams. And they wanted to maintain that. The problem was they were always going above. And that was when they looked at it from a year's angle, there was tons of cement that were going free to customers. So they desperately needed that to understand. If they didn't see it, they didn't know it. So the idea is to have materials as well as a focus point. So to understand what happens in the production, this is now looking at the tools. The MES, what it would do there, the MES normally would do the model management to understand what products and stuff like that. The product management, work order. If a sales order comes, then it gets converted to a work order. The work order basically is information telling the factory where this product goes to get manufactured. If it's product one, then it goes to machine one, then to two, then to five, and then it's done. If it's product two, then it's another product and it goes to another machine to get produced. So work orders basically give instructions as to how a product is to be produced or manufactured. The electronic dispatching, basically to make sure the work order moves through the shop floor. The production paperless factory, this is the ensuring that we have no pen and paper to make sure it's paperless. Real-time monitoring, making sure the information is live and therefore reactive for or analysis that are done later. OEE, the equipment analysis, plant analysis, and finally the business applications interface. So this is what the production management tool must do. The planning and scheduling, it's important, like I shared, if you don't have a plan, most factories do have, but some are still using outdated stuff like Excel. But nothing's wrong with using Excel. It's still a software tool and it still can create schedules. The idea is to ensure that when you're doing the integration part to bring that data in, but you can have dynamic planning and scheduling, which will allow you to react to issues on the shop floor and adjust your schedule for production based on that. Material management, like I shared with you, this is just defining a little more in detail. The warehouse management locations to monitor and understand where your materials are. The quality management, I'll be going a little more in depth, so I'm skipping here at this point, but I will go deeper as we proceed through the slide deck. Quality testing, all your quality stuff. Tracking and genealogy, very important for automobile companies, pharmaceutical companies. If they get a bad batch that is rejected from market, people want to know why, and they want to trace back what created that problem and why that batch was bad. So tracking and genealogy is an important space. Statistical process control, something that I've loved since I began my stint as a person working in industry. Statistical process is done manually currently, and people have some tools for it, but having it real time is amazing. Using simple statistics like X bar chart, range charts, and sigma charts can be very powerful on the shop floor if they're dynamic. Of course, then, like I shared, getting the maintenance people in, looking at preventive maintenance, breakdown maintenance, then spare parts management. And finally, if you have automation and there are enough devices on the shop floor, then making sure all that data is available in real time to be pushed into these systems so that we can then analyze it in real time. So let's go a little deeper now, and I'll break it down so that there are, and you can easily have questions here as well. If you'll have, I'll be happy to receive them. The production control, like I said, is about master data management. It should have screens like this, like I've got a sample screen here shown, which basically should be able to show me, what is my last month efficiency as to this month's efficiency, or what's the biggest problem that's happening in my factory now that's creating, my production loss, or what is the biggest issue related to quality, which is the biggest component that's doing rejects. If I just have simple dashboards which are web-based like this, then the production control module is actually doing what you wanted to do. The output should be this, but what it does in the background is basically making sure work orders are created. Material should be able to move on the shop floor automatically. Again, paperless, that means you're using terminals and software to help you do it. Paperless factory moves one step closer to saying, what if I need to do training on the shop floor? Can I also share a video of information related to a machine? So my operator says, I don't remember how this machine works, and he plays the video, sees the process, and then starts running the machine. So you could have even data right from drawings, videos on the shop floor, all digitized, because we are assuming that digitization has taken place. You have some type of PC or terminal there, which is web-based, and you can see this information and work with this information. OE is the calculation analysis and the web plant analysis, and of course the integration to the other software systems. So this becomes like the core module. Production is everything from manufacturing. It is the heart, without which no other department matters in an organization, especially manufacturing. So production is everything. So all the focus is given here, and therefore most of the things should happen at the production control. So whatever system is implemented, or whatever tool, should be able to provide these type of mechanisms to help the production system be most efficient. We were talking about web-based interfaces. Operators and supervisors on a shop floor don't like to be, bugged with very high level IT systems where they have to select a list box or a text box and click things and enter data. If it's visual like this, for example, here someone can select the activity, select the operator, select the machine, and select the order, because the order is telling me this is the order you can run. There's no order to run. Can I get more details? Yes, I can click on a button. Everything should be click based and visually ready for me to see, therefore making it much easier for operators to really work with the system. They prefer that. They are already used to electrical systems on the shop floor where they're pushing buttons. So the idea is to give them the same feel where they have just click mechanisms. If click and color codes help them, then simple web-based tools like this should be able to be exposing the information on the shop floor, making it really, really easy for them to work with the system that is coming in. So let's talk about a case study. I have a few case studies broken up through my presentation just to give you ideas on who's using it and why they're using it. And one of the favorite questions that come out for me during these points is that, so if I don't have any automation, then what? Can I put in Industry 4.0? And Bosch, though most of you will see that name and realize there's no way that Mihir is talking about Bosch. They most probably highly jump. In fact, Bosch is one of the were on the board. The head of Bosch was on the board for Industry 4.0 when it came out in 2011. But they do have in India, for example, Bosch has a manual assembly line, and there are industries like component manufacturing like them, textiles, agarbattis. These are companies that don't have machines per se everywhere, and things move very manually from point to point. And the challenge is, can Industry 4.0 really work for them? So one of the things we did with Bosch, they came up saying that it's a manual line. We know where the problem is, we don't know how to fix it. And the problem was simple. They were not meeting the numbers they wanted per shift. And they were asking us to see how to do this. We realized the problem was very simple. Operators were assembling components. That means they all sat on a desk somewhere. And as they assembled 4 screws in a component, they moved it to the next person. He did another fitting. It then moved to the next person, another fitting. It keeps moving to the next person till a final product comes out. So each of them have raw materials which they have to pick up and put into place for that product. And they have tools to help them to, a screwdriver set, an automated screwdriver, whatever. They have all of this that they work with. The problem arises when material gets over. So they have some material on the desk, it gets over. They have to go to the supervisor to ask him for more. And that's the challenge that they face. The supervisor was never there whenever they go there. And the supervisor has gone out for tea. And he's not available. They don't know where to reach him. And we did this project some time back when mobile phones weren't that elaborately available with everybody. And it was a challenge to reach them. And of course, the operators didn't want to do it. They were like, why should we follow up with that guy? If he's there, you should give it to me and I can produce. And this created delays in production. So we just basically created a very simple button-based system, again, touch, so it's very easy, where the operator could press a button. And as he presses the button, there's a screen, not even a PC screen, just an LED screen that was there. Not LED in terms of the TV that we talk about today, but like what we have on the railway boards and variable message displays. So we had that board there. The moment you press the button, it informed him that station 5 needs product. If you clicked another button, it said his tool is faulty. And the supervisor could then just get it from the store and bring it to that person. The problem was if he's not there. So if he's not there, this would escalate to an SMS on his phone. And if he did not respond to the SMS in time, then it would go up to his boss. In 3 months, Bosch managed to bring the numbers they wanted. In fact, they had a 7% production growth, which was fantastic for them. They were very happy because it was such a simple thing. Simple Industry 4.0 implementation where we digitized it. We made sure that whatever had to be said had to be pressed by a button. That event had to be captured and then displayed information digitally. And he had to then act on the data. Everything was digitized, helping them to quickly look at how to improve and increase efficiency. So manual-based factory systems where pure assembly is being done, absolutely a great candidate for Industry 4.0. So you can, and therefore Bosch is one of our greatest examples in terms of how they used a pure manual process to do so. Okay, going forward, we also look at how this information should be displayed on the screen. So if you're using technology that should be on the screen, you're looking at data-rich views for the users, okay? Large numbers. Can you see the numbers are big blocky numbers that should be easily visible to your operators so they know what they're doing. Are they reaching the quantities that they should? Because eventually it's all about that. Okay. I'll pause. There's a question coming in from Mamta Jain. Okay, great. Maybe I'll get down to a little more specifics with Mamta. She's asking a little bit of cost, but okay. Buttons, industrial buttons don't cost much per panel. It's very, very simple to invest and get. And also the LED panels are, now the rates have come way, way down. In fact, now nobody's using LED, they're using TV screens to do the same job. Like you're seeing the screen that I'm showing in front of you, I can easily pop this up in front of an operator and show him what's going on. So we can even use simple LCD screens today or LED screens that can do this. At that time, we didn't have the opportunity to have TV monitors that were 21-inch or 35-inch or 42-inch screens. But today, a 32-inch or 42-inch screen costs 25,000 rupees. So it's really, really cheap to show information there. LED displays also cost from that range to about 5 to 6 lakhs, depending on type, color coding, and stuff you want to do. The buttons are much cheaper. They're about 6,500 to 7,000 rupees per set. Very, very easy to put for a user. A little bit of electronic systems to capture this data and bring it to the computer and stuff. So that's a little bit about the cost there. Thanks, Mamta. That's a nice question. So coming back a little bit to what we were sharing, ideas to make sure that the information should be clearly visible. One of the reasons why people do not like a paperless system is because the information, they need a file and they can't, they use a file referring for data again and again. So when you have a large system that displays data well, then the operators start liking it because they're able to see exactly what they need. Next is, once you have all this information that's happening on the production, the next thing is to look at how to display this data for managers who need to act on this information. So you're looking at tracking and traceability and making sure you have all your performance analysis done in one shot. Easy it should be to see charts, pop it up for ranges and stuff like that. So this is the type of visualization that would help managers check out what are the top 5 losses in the factory, what's the OE currently, what's the machine doing, how long has it been inactive, and therefore it's not in production. This data should be easily visible to anybody and allow that information to come up with simple charting tools like this, which are dynamic, changing based on the shop floor. So that's the advantage of using simple and digitized systems. So when you use digital systems, the information now starts coming consolidated quickly and immediately available to managers to act. So that's a huge thing that that helps them to move forward. Next is to take it on the phone. Obviously, it makes sense that whatever technology you select on the shop floor, it should be mobile friendly. Senior management does not have time to open a laptop and see this. Therefore, they should be seeing it on their phones. Thanks to Wi-Fi being in the factories, senior people can and should be able to see the same data that I showed you on a mobile phone. So also, if the company is got a cybersecurity process in place and they want to put it on the cloud and expose this data for them to, when they're traveling, they should be able to do that as well. So you should make sure the tools that you select should allow these capabilities to make it most effective for managers to react. Everything about those figures that I shared with you guys before about the savings that a company does is only based on the reaction time of a manager. If a manager ignores this data, you don't save. Simple. Every delay is a delay that has costed you money, and therefore it's important the tools are there with them so that they are responding and reacting. If a motor is bad and it's continuously showing that it's creating problems in the shop floor, and I can see it pop up here as my biggest problem, then I need to take it and quickly indent for a new motor and get it changed. Management is responsible for making those changes, and therefore it's important they react and make it happen. But without data, it's tough to make those decisions, and therefore management normally holds back revenue or capex spending because they don't want to, because they don't understand it. But when they see data like this, because they have a lot of sense that they're losing money because that motor is creating problems on the shop floor. Similarly, if you're looking at the shop floor itself, you need to have different technologies. These are I've listed a few technologies that should be there in terms of interconnectivity to ERPs, to technologies on the shop floor, CNC machines. These are different things like MT Connect or OPC. These are all technologies that are used in a factory shop floor. So we are assuming that whatever technology is selected and the tool is used must support all of these as well. Or even technologies like XML and JSON, which talk to technologies in the cloud. Of course, having native drivers like Fanuc and Siemens makes a lot of sense because these are typical automation systems you see on the factory shop floor as well. So the second case study I wanted to quickly share with you is Cummins. It was Tata Cummins when we did there. And they are one of the industries that understood MES. They wanted it very badly in India. And their whole focus was, to manufacture an engine line. Imagine every engine to be manufactured every 5 minutes. That means it had to remain in the line. It was an assembly system. Quickly, the core engine comes, then parts are put in. There are 60 assembly stations. Each have hardly 45 seconds or less to quickly put in their part. There are testing stations. All of this happens rapidly. And without having a system that can actually be digitized would be impossible to do, because reaction delays where things are going wrong become very complicated when you have 60 stations running so fast that they need to shoot out an engine every 5 minutes. This created problems in the quality, because if they did not monitor and check what people were doing, they were having trouble. So they wanted their managers to be on top of it. They wanted real-time data from their ERP. They have an Oracle manufacturing system, and they wanted to make sure that the work order comes from there, it directly gets pushed onto the shop floor, and the production should begin. They had technologies like RFID, which they wanted to trace and track the engine on the shop floor. They wanted a barcode printing. They had a huge hand-on LED display that they wanted this data to be constantly shown on the shop floor, so everybody knows where delays are taking place. The main core reason was all this information was shown to managers, nobody else. The managers were the ones watching this data and watching that 45 seconds. If there were slight delays, they were reacting, getting it ready, and moving it. So they have been amazing. We have seen them produce. They use our system for almost now 12, 13 years. Yeah, 13 years easily. And they still use it. In fact, they have 2 lines for manufacturing engines, which they use it. So this is an example of an automated line, totally automated, but integration to ERP was critical, integration to testing stations was important, and yet making sure they produce an engine every 5 minutes. So it is an interesting challenge that we faced, and it's great that they gave us 2 lines, and they still use our system, so we still support and work with them. So it's amazing. This is one of the automated examples that I wanted to focus on. Of course, we talked about mobile, but how about technologies that are available today? For example, maybe a consultant to the factory could ask questions to the machines, and the machines could give data back. So there are technologies available now that allow you to make Industry 4.0 go to the next level, where you can actually ask a command, send a command, and it would automatically respond to you. You can say what's happening on machine 1, and it would receive the data and push the data that you're looking back to you. And you could even send data if you had permissions to do so. So this makes it very powerful, because then you get to know current status of wherever you are, just using simple chat-based applications like Telegram. Telegram is similar to WhatsApp. You can have Telegram, WhatsApp, different applications that should allow data to be shared dynamically with someone who wants the information, or who can give consulting based on this information. So we have large thermal power plants, for example, which need turbine tuning constantly. Then that information should be available directly based on a command, so that I know exactly how I can tune my turbine based on the parameters from a specific machine that comes out from there. So it's quite interesting. Of course, in India, I see this coming in maybe a year and a half later, but I can see that this is going to become a reality as well, where we'll have many more people interacting. So you can see, other than the plant people and managers working with the systems, you can have people outside the ecosystem of your factory also engaging with your system. Advanced planning, we shared basically to have, again, easy, dynamic, easy mechanisms to make plans, and it should be directly dynamic to the failures that occur in the shop floor. If the failure occurs, then the plan should change and tell you that you can't deliver material to your client on this date. It can only be delivered on so date, or on availability of equipments, people, constraints, in terms of what is holding this machine. If this one person is not there, then you cannot run the machine. So all of this can be put into planning system. Very powerful tool, and it's great to use because there are new lighter tools coming up. Manufacturing must adopt this, so that is dynamically connected to my shop floor. Materials, we shared a lot about that, where you have your materials, what are the stock levels currently, are they sufficient to produce a particular batch, and dynamically changing the stock in front, again making it very visually available, so that that product, if it starts going down a certain value, can I alert someone dynamically, so that they're aware of it going down, and ordering and filling up stores becomes a priority, so they can immediately get to know this here. So this becomes very powerful in terms of monitoring stock based on actual consumptions, because when you are dynamic on the shop floor, you are monitoring everything in real time. You're able to know exactly what consumption patterns are occurring on the shop floor. Most factory shop floors have weighing scales, measuring system, conveyor systems that can weigh systems. And because of that, we're able to dynamically know how much material is going where in a particular factory shop floor. And therefore, it makes sense to monitor the material movement dynamically. Quality features have charting tools that are dynamic in real time, so that you can put information here, and the quality people can directly print charts from here rather than plotting them manually, which leads to error. Again, digitization. If you're doing all of this online, then even the resultant analysis should be online, so they could do that. Visual inspection of the quality controls, doing tracking, and using SPC, which I shared to you earlier. I'm just giving you some sample shots so that you have an idea of what type of screens, what type of the screen should look like as far as information on the shop floor. Finally, the maintenance people, telling them how a machine is performing, what's the availability of the machine is, how, if you said it's available for 2 shifts, then was it available 8 hours plus 8 hours, or was there a missing link in between? Did it go down? Therefore, if it went down, there was a problem with the machine, then the availability comes down. This directly affects the measuring of my OEE, and therefore it's very important maintenance people know how they're managing this, how long does it take to actually service a specific equipment. All of these statistics become available, and analysis becomes powerful for maintenance teams to really, really become proactive on the shop floor. So this basically is the different departments we talked about: the quality, the production, the maintenance people, all of them coming together. Of course, the IT people, which is not mentioned here, but the IT people are very critical to make sure that they can help you to do this integration and bring all of this there. So then what is Industry 5.0? Industry 5.0 is basically taking all this data now that you've started collecting and doing some level of analysis, is to do a little bit of the AI and the machine learning space. So because of the cloud and IoT and systems that you don't need to own in your own premises, and you can push this data to do neural networks and do deep learning over long periods of time, it's making sense to start looking at systems that Industry 4.0 can bring that will also start doing a little bit of the prediction and help managements of factories to react to data much better and well in time before damage really takes place. Most of our plants are very reactive to problems that occur. We would prefer that we can start doing a little bit of the predictions as well. So one of the great ways to do this is to make sure that the real-time data that's coming in is to start giving predictive maintenance. That means if I know temperature is going up in a specific equipment and it's going to damage it over a period of time, then I'd like to know when that is going to happen, much before it actually gets destroyed or damaged. So maintenance people can act on it way before repair and get it back in working. A damaged equipment is far tougher to replace than one that needs to be serviced. So therefore, it makes sense to have predictive maintenance as core thought process when you're looking at proactive and making your plant more intelligent. Predictive quality, same thing goes with quality. It's a great idea to not wait for rejects to take place, but to get to know well in advance before they would cross quality limits, and therefore make sure that the response from the system is coming to you well in advance, so that rejects don't occur and batches can be changed and machines can be re-altered, so that, for example, capability of machines can be changed to make sure settings, setup are done properly, so that you produce a good product. And this is coming using the real-time data, so I can get alerted well in advance. If a batch is running, this data is available, it indicates to me the second batch will most probably cross the limit. And therefore, quality people have that opportunity to bring in management to change things on the shop floor. To close a little bit on what we're talking about today, is another case study called from a company called Cooper Standard. They're implementing some of the technologies that are new. Cooper Standard is a Chennai-based company, in fact. And they're engaging us on the SaaS model. So that means the service model is what they're looking at. They're a subsidiary for Ford, and they give parts. They do certain piping for fuel pipes to the Ford for their different cars. And Cooper Standard had a challenge that they were having. They didn't understand if their people were actually doing the jobs correctly. So they had a labor performance, per activity. They wanted to measure this. They were not sure whether they understood how to do the job and how much time they were wasting. They also wanted to make sure biometric identification is done. They didn't want someone to go type in somewhere, let someone, not know who was the person responsible on that machine. They instead of someone saying that person was there on the machine, they had to scan themselves and through their fingerprint analysis. So it's incredible that we are integrating biometric systems on machines as well. They wanted machine performance, predictive maintenance capability, whether the machine is really doing what it's supposed to do based on the parameters that they've set. and finally they wanted to do OEE. So you can see this company is a little more modern in terms of the previous two that I shared. They are already moving in the Industry 4.0 focus. We have just begun something earlier this year with them. So they are actually one of the few clients who have come to us saying Industry 4.0 implementation. That's their requirement. And you can see by what they're looking at asking us to do, it's very much focused on getting there. So we're currently implementing this project. I thought it's a great idea to share a little bit about Cooper Standard as well, because they are based in Chennai as well. And we are visiting Chennai regularly to help them get there. Just the starting period has been great. They've already started seeing this data and they're quite excited, and they're looking at implementing it, for many more of their lines as well. So this basically allows me to close today's session with Industry 4.0 for manufacturing. I hope that I was able to give a good idea of what could be used and what type of tools should be on the shop floor, what are the different departments, and what can be done in terms of Industry 5.0 by bringing predictive technologies to help to warn maintenance and quality people before things go bad, whether it's an asset or it's the product itself. So this covers our session today for Industry 4.0. What I'd like to have is questions come out. Saurabh, if you're there, I'd like you to help me as well as I go through the questions, so it'll be easy. I can see that we have a question from Jayashri. Okay, great. On the product quality aspect, she asks, is technology available for auto recognition of product defects? Oh, yes, very much, Jayashri. There's a lot of technologies available for auto recognition. It depends on what you're doing and how clear the environment is for those particular parts. If they're mechanical parts and they're moving through a line, it's very easy. They're reasonably expensive, but they are also quite reliable nowadays. At one time, the reliability was very poor, but technology for auto recognition very much is there. In fact, they can be built in such a way that they can tell you what is passed and reject very, very at high speeds as well. I have seen it in the bottling industry. We have done some work with Coke, and we know that Coca-Cola, the bottling industry, is all the conveyor systems there which are moving the bottles have such systems in place. So whether a cap is fitted or not, they can immediately see, otherwise they can reject it. So that's there. How MSMEs have adopted 4.0. Super. I think Ratna, that's one of the very, very important questions to ask. So MSMEs, so yes, it's a challenge for MSMEs because they are interested in just producing. They don't have necessary capex in hand to spend so much money, and therefore they have challenges in terms of how will they go about doing it. But thanks to, like I said, the SaaS model coming, that is software as a service model, there is maybe opportunities opening up for MSMEs to start looking at 4.0. Not many have, some have. Many are investing maybe at trying to do these projects on their own with local software companies in the area where the MSME is. We have seen a lot of companies in Maharashtra where they work with local software companies. It's a challenge to work with them and get it done. It would make sense to go with companies that have knowledge, but MSMEs want to get there. And I think thanks to the software as a service, they should be able to get there. I normally see companies at the 50 crore, 100 crore mark turnover, looking at maybe at Industry 4.0. Below that seems to be a challenge to most companies. So if you're looking at a turnover perspective, that's the type of turnover. In fact, maybe higher sometimes. So it's easy for everyone to understand. Another question is typical timeline to implement a full-blown 4.0. Wow, great. Ramani has made sure I have the toughest question to answer. If most automation is in place in a factory shop floor, a full-blown 4.0 should take anywhere between 6 to 8 months to implement, phase-wise, preferably, line-wise, preferably. So even though it might take longer, the idea is to bring multiple systems to start using the system and collecting information. So if everything is modular, and I shared with you some slide on the different type of modules, production, if they are available and they are modular, then it's very easy to implement on the go. That means literally you can have a line up and running with Industry 4.0 in maybe 3 months. And therefore you can start seeing performance directly on that line, then move to line 2, move line 3. If there is no automation, then to implement and timeline for a full-blown 4.0 is kind of challenging because it involves investments in terms of automating processes, buying material for that, then capex come in, approvals, budgeting for companies. It becomes a challenge. But if it's already reasonably automated and they have signals which can be tapped, then value add is very high. If the attitude is right, I would say my timeline truly depends on an attitude of the management there. I think Industry 4.0 is a top-down approach. You start with heads of companies rather than starting from bottom. So if that gives a little idea on the type of timeline that's there. I hope I answered your question, Venkatramani. Ramesh asks, considering simple manual process like Agarbatti, can you explain how this is implemented? Lovely, super. So Agarbatti, if you know, it's all about people, and of course, a little bit of what formulations as well in terms of what essence I'm using to put in. So you have a little bit of the quality there. But because people are there, you normally have supervisors. In most Indian manufacturing, operators don't directly type data because it's impossible. We ask supervisors to have touch-based screens which they can use and just click. So let's say you have an order coming from providing 1,000 units of an X Agarbatti brand and you want to produce it for your customer, then they just click that customer and they click what needs to be produced. That's it. And they start the process. They assign an operator. They assign operator just by touch, saying this operator is going to be doing, maybe the rolling of the sticks with the formulation on top of it. Someone is responsible for making sure the essence is correctly put in. Some places you need to do some treatment. So depending on that, each of those processes, the supervisor manages who's doing what. Though it doesn't give a lot of real-time numbers very clearly, or like I shared what we did with Bosch, you could have buttons that help you to just press and tell you that you have started this activity and you have finished this activity. Even if you're able to just start an activity and finish an activity, it has huge value in terms of analysis, because that immediately tells you where gaps are occurring, where delays are taking place. So it's incredible. Even in simple things like Agarbatti, you can actually look at focusing on using simple touch-based systems or simple button-based systems on the shop floor wherever it's implemented, and then the management having this data so that they can act on it. Most Agarbatti owners, some of them are reasonably large that we know, and they can have, but it's normally singly run by a single owner. So it's best to have him drive this, because in his heart, he should be clear that he's looking at analysis and improvement. It's never about firing anybody, because you can see the analysis. It's always about improving, and therefore you find better ways to do it. I remember one of the Agarbatti manufacturers talking to me and asked me that I have a machine which does drying, and I want to know, energy consumed. I said, how big is the machine? So he wants to know that. He's interested that did I buy the right machine? Someone sold it to him and he was disappointed, and he's not very happy whether he can do it better or not. So these are a few things that start popping up. If you bring them into a process like a manual process like Agarbatti manufacturing, you will gain incredibly, because you start seeing the information for what it really is, even if it's slightly skewed in terms of per second kind of data. Even if it's a few minutes up and down, it doesn't matter. It starts giving a picture of how things are moving. And when you validate, because eventually a batch needs to be made and it needs to go to stores and needs to be shipped. So from beginning to end, you start getting to see where things happen and how long it takes. And all you can do is then improve those areas. Go to the people there and say, how would I make it faster? And therefore I have more Agarbattis per hour done rather than that. So I hope I answered that, Ramesh. If you have more queries, please feel free to ask. Okay, there's another question here. Deepak says, when you say SaaS, do you go by number of transactions? Okay, great. No, normally SaaS models are simple. I think they're just basically whatever capex that you would look at putting in normally would just get divided on as a monthly mechanism, making it easy for you to pay maybe 50,000 a month, or 25 to 50,000 or 70,000 a month, rather than paying 50 lakhs at one time, buying all that stuff. It's easier sometimes to pay that per month. So it's not on transactions. It doesn't matter. The SaaS model should not limit it to transactions, though it can. There are models where cloud models that we are aware of that basically need you to have number of assets, number of transactions, then also the amount of data you're going to put on a cloud. But if you run SaaS models with on-premise type of applications where you have the computer at your premises, then you don't need to worry about that. Then you don't have to worry about data because it's not on your computer itself, and therefore you can still run and do the analysis. So SaaS can go different ways. Cloud-based guys like to prefer put it on transactions, but it's easier said than done. It's just some value that's divided across, and it should make sense to you per month to pay. The reason they break it per transactions in terms of per machine, per number of transactions, just so that it makes it easier from a customer perspective to quickly budget. If he adds 10 more machines, what would the cost increase? And it becomes easy. So that's a great way to do it. We normally, I think even our sales team would normally do that. We would normally make it per machine, the number, so it becomes easy, or per asset, or per, per unit that they are working with, making it much easier for them to look at the cost. So yeah, I hope I answered that question. Revati says, can we know which cloud server is most predominantly used in manufacturing units? Okay. Okay. Very, very, very good. Excellent question. There are there are dedicated cloud systems coming in from automation vendors like Siemens, ABB, and large IT companies like Oracle, IBM. They all have solutions on the cloud, and predominantly, obviously, the clients are their existing clients. They're trying to push them onto cloud. We have done a lot of work with Oracle, where Oracle wanted us to join them to their manufacturing uh, customers and work with them. And we found that people don't engage on the cloud services yet. Though people are doing, they're more on test phases. Some have gone ahead, and maybe customers who have many plants across the globe, like for example 50 plants across the whole world, we'll look at cloud solutions and move there. So predominantly, there's no one specific. There are free versions, and like I said, if you are already a OEM like Oracle or Siemens or ABB, you are able to engage your direct clients. So people normally would prefer, if they already have a large ABB system, they prefer to go with ABB. If I have a lot of Siemens system, I prefer to go with Siemens, because then I know I can go to one guy and get all my information that I'm looking for. So there's no one such company or cloud service that's there. There are many, because all are not focusing on overall manufacturing. Some are focusing on very specific segments. There are cloud services just for pharma. There are cloud services just for discrete manufacturing. There are cloud services just for plastic manufacturing. So people are playing with the model a lot. It's because their domain knowledge exists in that space. They created something there. So you'll find that there is no one real cloud service that's providing the most number of them. I think in value wise, Revati, I think in value wise it might be the larger companies, because they will charge that much higher. But otherwise, I don't think there's one. We haven't seen one typical one being out there. Wing Commander Arun says MES provide plugins for enterprise systems. Okay, great. I assume enterprise systems would be ERP and other systems that would be running in, maybe planning and software scheduling systems. If that's the case, the standardization, the plugins are there. Of course, they customize to a bit level, because you need to know what data you want from those systems and what they can share. So a little bit of work is done, but it's reasonably much easier. The plugins make it really simple, and normally use database backends to push data back and forth, making it much simpler to push data. But yeah, a bit of standardization and work and customization is needed. Sometimes we are working with companies, they have enterprise systems, but they prefer not to give you direct access to it. Therefore, plugins can't do anything, and you need to basically have systems that would import information from them. Maybe they push data to you as XML files or CSV files, or different other ways, and then you need to import that data. So sometimes it changes. If I can't use a direct plugin, and I would need to maybe import data. But those tools are available, and MES normally does provide those type of tools. But there are a lot of companies providing that intermediate service as well. I think we get many requests for that. Lakshmi Narayan says, post-COVID, how will touch-based sensors such as biometric sensors be looked at for data collection? Okay, great. So as I shared, Lakshmi Narayan, biometric sensors, we're lucky to see it already coming into operation for us with the last customer I shared, Cooper Standard. They actually have brought it down to the machine. That means customers are really getting focused on efficiency of the man, of the person, which is quite nice, because people always thought about the machine, but they never thought about the people. And people are an important part of any efficiency calculation, and that's missed by putting biometric sensors. I have a feeling it's not going to happen that soon. But I know what you mean in terms of code being the reasons. But because we have gloves and stuff like that, in industry normally can easily put on gloves and touch buttons and stuff like that. Therefore, they don't have those issues. Plus, with sanitization being there as a major need for manufacturing to make sure it gets done, wiping of buttons, all that is happening. But biometric will be a challenge for COVID, because obviously I need to use my finger and I can't have gloves, and therefore biometric sensors do pose a challenge. But from what I'm seeing is, and based on the sanitization systems that are being implemented in factories, I think it should still continue. I think the proof of concept would be for us to close this project with Cooper Standard, and I would be able to give more concrete data to you then. But I know that they are not removing the biometric sensors because of COVID. So I think it will only grow. It won't go down. Um, Mamta Jain says +1 Agarbatti production supply. I think I already answered the Agarbatti part. If there's anything specific, please let me know. We have questions from touch-based sensors could be replaced by face recognition. Oh yeah, of course, yes, Revati, you're right. They could. All of this is work in progress. Face recognition is not the best today, but yes, it could. I think it will automatically catch up because we will start moving into technologies that will, replace touch-based systems, and it'll be easier to move. In fact, the current technologies, the screens I showed you, for example, which are web-based and all, and have large buttons, are all can be set up using gestures. That means I don't need to touch the screen anymore. Gestures on a PC are already a reality, and even having augmented reality is one of the things that Industry 4.0 also asks customers to look at as a technology to focus on augmented reality, so that you just have a glasses on and you can see your machine and your screen. You're actually you're clicking things in the air, and therefore there's no question of touching anything. So these systems will surely garner some movement. The only problem is that they are very sophisticated. They cost a lot right now, and they seem too sophisticated. And getting them to our operators seems to be a challenge. But I know their growth will increase trajectory, because we have been trying to look at these systems for a while. Customers just ignore us today. But thanks to COVID and issues related to touch, they should change the market interest in all of these technologies that are coming now. So they've been there, they've been tested, but I think they'll catch up. Yeah, I think a year or two, that's it. And we should see a lot of them more on the shop floor. So more people wearing glasses with doing augmented kind of reality, which would be very, very interesting. I've been looking forward personally to such technologies being on the shop floor. Okay, great. Professor VGS, that's all I have of your name. Is there any open source software available, any demo, educational? Oh, yes, of course, very much. For educational, always that options do exist. You can even get in touch with us later if you wish. Yes, there are many ways to have students understand what this means. I have been fortunate enough to work with a few colleges, Congo Engineering College, VIT, where we talked about starting courses for students to get into these areas so that they understand efficiency. Not only do you understand automation and electronics and instrumentation, but you also understand how IT systems, which are becoming a need, become the default tools. And having students, of course, you don't get all students engaging in such activities, but even if you get 10% of students in educational institutions actually using the technologies hands-on, the value is very, very high, because they know now what industry looks forward to. And knowing what efficiency means, is that means a student joins an organization understanding that concept of understanding why things should be better than what they were before, and why an IT system makes sense to collect information from a factory shop floor. So I think that's a wonderful question. It's something that I've been, again, close to me, but I haven't had much of universities really working with us, to really take this very, very seriously. And the ones that did, we saw a very small percentage of students actually interested, because they couldn't put it in the curriculum fully, but they added it to curriculum for their students. And there were just about 10% of the students trying to engage in those type of stuff, because most people just want degrees, unfortunately. But yeah, we're looking at hopefully that they also want to get engaged with what manufacturing is really doing. Another question from Shankaran. This question might be off track. He says, any case study bill of agricultural farm offline monitoring? Wow. Wow. This is great. Sankaran, lovely question. Not in India. I have done an application in Saudi Arabia, very strangely. You will think there's a desert there and no farms, but the north of Saudi Arabia actually have automated farms where sprinkler systems are running and have to distribute water on farm areas that they've allocated. There is hardly any manpower there. And the way they do this is they work with universities. So you can put IoT there. The way to integrate it is to understand crop patterns, amount of water that needs to be given to a crop for a particular period or particular season. And based on that, you can have IoT and 4.0 principles put together to actually do this. I've seen it work, so it's amazing. And we have agricultural institutes publishing this data online, and then the manufacturing or the farm agricultural systems taking this data directly from the the patterns of weather and stuff like that, and then automatically distributing water that is needed, or the chemicals and things that are needed for agriculture. So it's incredible. It's very much there. I'm talking of a concept that was true 15 years back. So I see 4.0 very much in this area. India would be an amazing place to look at it if we can start thinking there. The problem is most farmers don't have that type of finance to look at it, but it's an incredible process. And with now the pumps getting to be solar, and you can automate pump water flow into fields, I think it's a great thing to look at. So it's not off the track, by the way, Shankar. I think it's an incredible question, and I'm happy you brought it up. For India, that's something that we should be looking at, making our farmers really, really powerful there. Basant asked me from where can we get a vendor list for taking IO. Okay. Well, I'm sure if you use Google, you should be able to pull up a lot of stuff for IoT and Industry 4.0. Of course, you can always connect with me as well. I'll be happy to help you to get people connected to it, because there are a lot of vendors that come into Industry 4.0, not only people doing maybe the IT systems. You have ERP, you'll have automation vendors, you'll have people who would be selling quality systems. You'll have people who are actually producing technologies like RFID, barcode readers. So there are many people that come in, or even now what we talked about with the non-touch based systems, we're looking at using augmented reality or different other technologies. So vendor list is a large list. I always recommend, if you just want a vendor list, it doesn't make sense, because there are multiple pieces that come together to form an Industry 4.0 space. So it's great to do consultancy before, understand what's needed, and then phase it over a period of time. Never to do it in a hurry. So not just get someone who will say we can get you Industry 4.0 ready, because there is a cost to it, and you must be aware about it, and you must clearly define a year-on-year movement towards it, and bringing more and more systems to get them digitized. It's not so easy as everybody thinks that it is. It requires that time. It just needs intent. If the intent exists, it's very simple to get to that point, but it requires time. So there's a huge vendor list. Like I said, many technologies. I don't have that now, but I'll share it later with someone else, where I can share with you the different technologies, and then that you could search for vendors in each of those technologies, and maybe get an idea of what type of vendor lists are available for each of those technologies. Jayashri asked me again with reference to data collection on a factory shop floor. Companies move from paper model to manual data entry instead of automatic capture from machines. For smaller companies, its investment is too high to make this direct transaction. Absolutely right, Jayashri, correct. Therefore, manual data is critical, but to move from the paper model, just make sure that the manual data can be done by touching, captured using a touch system. Therefore, eliminating the automation part, which is very expensive, but ensuring that at least data capture. Like I told you, Bosch, though they're a rich company, what we did for them was just to make sure they press buttons, make it as simple. So people will do manual, and data entry is a bad word for me now. I would say let them select or pick information by using touch-based systems, making it really, really attractive for smaller companies to also focus and still ensure if the business owner is really proactive, I think he can do amazing stuff. He can become easily knowledgeable about his process. He doesn't have to depend on people telling him data. Data will give him great analysis on the shop floor. Agarbatti is another good example there as well. Can you share details on IoT kits, such as what they contain, effectiveness in filling the gap? Okay, great. That's a very large question. I'll try to quickly address it. IoT is a very, very dynamic space. The kits that you talk about are still at a very lower level playing field. Mr. Swaminathan, they're not exactly advanced enough to reach, but they're exciting. People want to capture temperature, sensor, maybe other parameters you can. Of course, for industry specifically, IoT kits are different. They need to be rugged, so they obviously cost more, and they need to be able to capture the sensor data directly. What we all forget is sensors are an important constituent for data, and sensors cost money. Therefore, can I tap that data using IoT kits that will bring that information in, as well as be able to sustain itself on a factory shop floor? When we did the project for West Bengal State Electricity Board, I remember we going there, and no, I think it was MP, Madhya Pradesh. Madhya Pradesh guy called us and said, I hope you have gone and seen our substation. If you go and see a substation, we have a bus bar, which is where the large voltages are there. He said, if you go there and you try to put any electronic device, they get fried. This is what he told us. And he said, I doubt whether you'll be able to actually implement IoT with us. And of course, we were lucky because we were clear when we design a box. Like I shared with you earlier, one of our focus areas is to design the IoT box. It should be made for the application. And therefore, when you think of it, should it work on Wi-Fi? Should it work on remote technologies like GPRS or 3G? All of these factors. Does it need an Ethernet port? Does it need a serial port? Does it need an IO capability to get center data directly? So many things define the IoT per se. And therefore, it's not, again, something that you should decide quickly. You should carefully understand what's available. And like I said, I would always prefer that you look at designing something for you. Ask something really, really specific that makes sense for you. So I hope I answered that question for IoT. I have Subhudi asking me, you said 50 lakhs one time or 50K per month. How would you be able to manage providing 50 lakh solution but recovering 50K? Okay, super. Good question there. Different modalities. Of course, I'd love to send you to my sales team for that. But Subhudi, a good question. It's simple. If you pick software that does not look at per unit type of costing, then it's easy. Then it's a X value divided by so many months, and therefore you can achieve such numbers. And normally it depends on the tenure. It might be that we take the capex investment and break it for 5 years or 3 years, and therefore we can play with the monthly number that needs to come out, making it slightly easier. The beauty of COVID and what it's pushing us to do is to become flexible. Can I come to you and say, no problem, tell me what value you want to pay per month, and let's work on that. And then we start, working towards a mechanism there. So if SaaS models can be are evolved based on customers' need, then the value is really, really high. So I hope I could do that. I have many more questions. I hope I can answer all of them. Okay. Can small manufacturing companies do it phased out? Absolutely, Ratna. That's the way to go. Always look at phasing out implementation of new ideas and new technology. It's good to consult, to understand, get people to come and talk to you about it, come people to see your factory, understand what segments you can focus on and how you want to evolve it. Absolutely. Everybody must, but trust me, large manufacturing also cannot do that. It's very challenging them to get capex in these times, to invest a crore and a half. It's just impossible. And therefore, it makes sense that everybody look at it phase-wise and understand each component that they need. Do I need augmented reality? No, I'm fine with touch. Then I can scrap that. Do I need to use a specific type of sensors? All of this you can work with. So it's interesting to focus correctly, and therefore picking technology, what should we pick and what can you spend on today is very important. We had a recent encounter with someone who was trying, they manufacture panels, and it was interesting. He was a progressive business owner, and he was like, I need to understand whether I can do Industry 4.0. I said, yours is a manual process, you can. But when he thought about it, he said, Mihir, I think I'm missing the ERP first. I said, perfect. So he took a call that ERP would be his first cost. He would spend money there, make sure all those processes are in place, and then maybe move on to the factory shop floor. So it's important business owners prioritize what cost to do this year and what to budget, and therefore move in that direction, making it much easier to then make cost to the savings ratio meaningful for each one. I have Shanmugan is saying, for a company doing a turnover of 35 crores, do you think? Absolutely, Shanmugan. Again, same. I'm answering similar to what we talked about before. The idea is to make sure 35 crores is very much a decent figure to look at. Implementing can be phase wise again. Best way to do it, of course, is to come and visit you and understand. That always makes a lot of sense, and makes sense to then focus on understanding what to do first. And like I said, look at it over at a time. So when you start saving, you don't mind investing again. Everybody, you don't implement Industry 4.0 without getting money back. If you're not making money, then don't spend. It should be something that you're getting back. So it's great to do it phase wise so that you have proof of concept for yourself that if you spend X, am I really getting the Y that's taking care of that cost plus more? And if it is, then move to the next phase. It's the most sensible way any business owner should focus. It doesn't matter on the value of your company in turnover. It should just be the attitude and a clear focus on return of money. There's another last question I think I'll take, which is basically, what are the lifespan of hardware sensors? How do you manage servicing the hardware? Okay, great. Raja, it's a great question. Hardware sensors, yes, there are failure rates, and depending on where you're buying them from, can fail. We normally work throughout the country and abroad as well with partners who are local to those cities who can go and service those particular parts. So it become much easier to go and replace them. Obviously, we'd recommend you to use better quality sensors so that they last longer. Some of them have clear life cycles of 10,000, press button on and off. They clearly define those. A good thing using Industry 4.0 is you can actually measure that, and you can tell the OEM that you bought it from whether it is actually performing as per their needs. So that's some way Industry 4.0 can help, because you digitize the data and you can then start understanding the life of hardware and equipment that you have as well. I think is very, very powerful. Um, I guess that's it. I think my colleague seems to be online. He's given you my details as well. So if you want to copy that, you could do that. Saurav, I think I've done, and we are out of time as well. It's 5 o'clock, and therefore I'd like to close the meeting right now. Saurav, I leave the meeting.
Yes, sir. So on behalf of Tai Chennai, I would like to thank you, sir, for taking a time off your schedule and giving it to our participants. It was I'm sure our participants would have loved it. It was such an informative session. So thank you so much again for doing this.
Great, sir. Great. Thank you so much. Lovely set of members. Lovely to see the questions here as well. It was interesting to have these type of questions come in. Okay,
sure. Yes, sir. Thank you so much. I'll be ending the meet now.
Great. Thank you. Bye, everyone.
Thank you.